Hello everyone and welcome back to another video. Today we are going to learn about a new data structure called stack. So what is a stack basically? So you must have heard the word a stack of newspapers, a stack of pancakes and all and etc. So in computer science the data structure stack is also similar to a stack of newspapers, a stack of pancakes. So a stack is what is called a LIFO type of structure. LIFO or FILO. So LIFO stands for last in, first out. So LIFO stands for last in, first out, and FILO stands for first in, last out. They both mean the same thing. So what this basically means is whatever data you put into this at the starting, it comes out at the ending, and whatever you put at the ending comes out at the starting. So this might be a bit confusing to visualize if I just tell it in words like that. Let me draw it. So you must have seen, these CD holders. They that can be a good representation of a stack. So you store it's an empty container like this, and you put a CD down. So this is the CD which you're putting in first, and then you put on CDs on top of it. You keep on putting CDs, so they stack upon each other. So this thing can represent the stack. So now if you want to access the first CD which you want, you have to remove every CD which you kept on it. So that is why the thing which you kept in first, you can access it at the end. That is called first and last out. And similarly, the last CD which you kept, this one, you can access it immediately. You can access it the first CD. So the last CD which you kept can be accessed first. So hence the last in, first out, or first in, last out means the same thing. So this is a small a real life intuitive example for a stack. So now let us see what operations we can perform on a stack. So generally a stack has the following operations. It has an operation called push, an operation called pop, and an operation called peek. It also has helper functions called isFull and isEmpty. So I'm going to show the logic behind all of these functions, and then we are going to program it in C. So now I'm going to tell you what the push operation does. So assume you have a stack. You can think of a stack as a container with a bottom, which you can access only from the top. So a topless container. So I kept something at the bottom, and now I want to add something else to it. So I'm pushing something else onto the stack. I'm pushing it. So this is what is called the push operation. And then similarly, pop is just the opposite of push. So if I have a stack and I want to remove the top thing, if I want to remove the top thing and access it, that is called pop. I want to remove it and delete it from the stack. So that is called pop. And meanwhile, peek is almost same as pop, but there's a slight difference. Peek means I just want to look at it. I just want to look at the top element and see what it is and note it down, but not actually remove it from the stack. That is called peek. Okay, my drawing is very weird. Okay, this is me looking at the top element, peeking at the top element. Okay, that's the peek. So what the difference between push and pop and peek is? Pop deletes the element from the stack, but peek doesn't delete it. You just look at it and you note down the value. But for pop, you note down the value, delete it from the stack. Push means you're adding something onto the stack. Is full and is empty are, I think, pretty self-explanatory. Is full just tells us if the stack is full. Is empty tells us if the stack is empty. That's it. So now let us look at how we can implement this. Uh, there are two ways actually to implement it. One is using an array and one is using a linked list. So in this video, we are going to implement the stack using an array. In a future video, I'll also include this representation. So this I'm going to do it in the future. Today, we are going to do it in the array, in the in an array. So yeah, let us look at how we can do it. So the first thing you need to do is you need to take a very large array of any size you want. Let the size be, let this be array, and size be some cap. Let's represent it as cap, capacity cap. So this is gonna be my array. It has many indices. It's a very large array, and so on. It continues. So what I have is I have this array, and I also have a variable named top. Top, it keeps track of the index on which I last inserted a value. So in context of a stack, okay. So assume I inserted 1, 3, 5, 7. My top is going to point to this index. My top is going to be 1, 2, 3. My top is going to be 3 in this case. If I inserted 8, my top is going to move to 8 and my top is going to be 4. So it keeps track of the topmost index. That's top. So I'm going to store it in a structure. I'm going to create a struct stack. In that, I'm going to statically make an array statically, int array, and its size is going to be cap, and I'm going to have a variable top. So this is how my stack structure is going to look like. So now let us go on and implement all of those functions. Okay, the main important function, the starting function to initialize the stack is init. Even this function is also there, which we are going to implement. Okay, so now let us implement the functions. Next page. Okay, why am I not able to go to the next page? Yeah. Okay. So let us implement the initialize function, init function. So what do we need to init? So initially, when I create my structure, this I'm going to create an array of size cap, and because we are doing it in C, and it's gonna be filled with all garbage values. We don't care about these values. And then we are also in our structure, we also created a variable named top. Top will also have some random garbage value which we don't care. So to initialize it, we want to set top to this to an empty stack. So initially we should make it such that it looks top represents an empty stack. So what would be the index in case of an empty stack? 1, 2, 3, 4, and so on. So you might be tempted to say 0, but is it really correct? Because if my top is pointing to 0, it says that there is one element which I pushed at the index 0. So that doesn't represent my empty stack. So therefore, we initialize top to -1. So empty means our is top is equal to -1. So now let us look at our init function. What are we? So we don't have much to do in our init function. We just set the value of top to -1. So our init function is going to be, it's pretty simple. I can just write it. Init. I'm just writing the pseudocode. Set set top is equal to -1. That's it. That's my init function. Now let us program this function real quick. I'm going to my terminal. Yes. So yeah, it's going to be a. Let us define the stack structure and program the initialization function. Let's get started. So we'll include stdio.h. As we don't have to do any dynamic memory allocation and all, I'm not including stdlib. So yeah, let us define our structure, struct stack. In that, I'm going to have an array of length cap, size cap. Oh my god. Okay, size cap, and an integer which represents the top index of the stack. And I'll just put the semicolon after declaring a stack. So here I'm going to define cap. I'm not going to put a number. I'm just going to define hash define cap. For now, let it be 1000. Let it be 1000 for now. So yeah, this is our stack structure. Now let us do and let us write the initialization method. Void in it. It doesn't return anything, so I'm putting the return type as void. So what do we give as the parameters to the function? We give a reference value to our stack. We send the pointer to our stack so that any changes made within this function reflect in the entire program. So we pass our stack by reference. So our pointer is going to be of the type stack star. So it will be a struct stack pointer stack status. This is all I need to pass. So how do I need to? What do I need to do? I just need to set the top to -1. That's it. This is my init function. It's nothing much. Pretty easy. So yeah. Now let us go to the next function. I'll connect my stylus. Yes. What is our next function? It's the push function. So let us implement the push function. What do we do in this push function? So assume we have a stack which is partially filled. So 3, 7, 8, 19. And my top is currently over here. My top is equal to 3, index 3. Indexing starts from 0, so this will be 3. So now by pushing a value, if I want to push the value if k, I want to push k, what do I need to do? I need to add something at the index 4. How do I know it's 4? My current top is 3, so 1 greater than my top. I have to insert over there. So 3 plus 1 is 4. And there I have to insert this value k. So what do I need to do? So I just need to increment increment my top and then set my array of top is equal to the value k. And this top, however, is the incremented top. It's the new top of the stack, not the old one. We do it after incrementing. So, but there's also one error which we might run into in this statement. So assume I have filled my entire array 25, 30, 31. My top is currently pointing to 4, 5, 6. So in this case, my array size, array size is 7. My cap is equal to 7. So my top is pointing to 6 now. Now what if I want to insert? There is no more space in the array. I cannot insert. So I also have to perform an out of bounds check before that. Okay, that's it. So I have to check if my array is full, and then if it's not full, I can push. But if it's full, I have to return 0. I will return 0, indicating that the push operation was a failure. Okay. So before this, let me write the helper is full function. So is full. This is pretty simple. So I'm going to have my array, and this is going to be cap. Assume I've filled it with all values. So my top points to the last index right now. Top is equal to cap minus 1. So now if my top is equal to cap minus 1, I can infer that my stack is full. So basically, the logic behind this full is I can write it in one line. I'm going to return if my top is equal to cap minus 1. If it's not equal to cap minus 1, it's of course I can say that there's some empty space in my array. Uh, okay, strictly speaking, it should be top less than, okay. If it's full, oh, yeah, it's going to be equal. So we know that our top will not exceed cap minus 1 at any stage. We are going to catch it when it's equal to cap minus 1. So we are not going to use any greater than. So we'll just return if top is equal to cap minus 1. That's it. So this is how we do it. And now I'm going to write my is empty also. That's also very similar, but so is empty. We already talked about how an empty stack will be represented. That is when we initialize it. We set our top to -1. So -1 index doesn't exist, but we set our top to -1. So to check if a stack is empty, we just check if my top is equal to -1. That's it. So yeah, this is our is empty and is full. Pretty very basic function, like it's just one-liner functions. Okay, now let's implement. Now let's see our push function. Let me write the pseudo code for our push function. So push. So first, check if stack is full. Check if full. If it is full, return 0, indicating failure. Otherwise, else, increment top and then set array of top is equal to whatever k or value I'm pushing and return 1, indicating success. Now let us program this. Again, the program for this is very easy, not a big one. So yeah, let us program this. We'll put our return type as int as we are returning if it's a success or a failure. You can also put a bool, but I'll put an int. So push. I'm passing. What do I need to pass? I need to pass a reference to my stack, and also I need to push the value which I want to send the value which I'm going to push. So what do I do first? I check if my stack is full. So let us implement. Okay, let us implement is full and is empty functions here. So int is full. I just need to send a reference to my stack. What do I need to do? I just need to return if my stack stop is equal to cap -1. Return my stack stop if it's equal to cap -1. Now let us implement is empty. That's also pretty simple. Is empty. Oops. Status. We'll just return if the top stack stop is equal to -1. Stack stop is equal to -1. That's it. This is how you implement the is empty and is full. These are these won't be used directly, but yeah, these will be used inside our push and pop functions. So now, what was our first step? Our first step was to check if the stack is full and return 0 if it is full. So I'm going to check if the stack is full by calling my is full function. So if my is full of my stack, I'm just passing the s which I got, the pointer is equal to 1. So is equal to 1. Let's return 0 because we cannot. So if my stack is full, we'll return 0, indicating that we cannot push this element and it's a failure. Else, you don't need to write the else because if the condition is true, the function is not going to, the code won't execute further past the if because we have a return statement in the if. So we don't need to write the else statement here. So otherwise, what to do? We have to increment top. So what do we need to do? Increment top. S dot s top plus plus. We increment top, and then we do array of the new top is equal to the value, and then we return 1, indicating success. So now here line 28 and 29, I can compress them into one line. I can use the pre-increment. So instead of writing two lines, I can just write plus plus s top. So now our top gets incremented and then that index gets accessed by the array. So we can reduce those two lines into one line. Okay. Now let us look at the pop operation. So back to my thing. Yes. So for the pop operation, we just have to do exactly opposite of what we did for the push operation. So pop. So what do we need to do? So, okay. Now let us assume we have an empty array and they're asking us to pop it. There is nothing to pop if it's an empty array. So we can return a failure in case of an empty array. So first we check for an empty array, and then if the array is empty, we return 0. Otherwise, if I have some elements like 2, 9, 8, 7, and my top is here, 1, 2, 3, these are the indices of the array. What do I need to do? I need to return the element which is at the top, and then I have to decrement top because I removed one element from the stack. So the top also must decrease. So what do I need to do? So first I should store the element which is there at the top and then decrement top. That's it. So let us write a proper like pseudo code for this function. First we check if an empty array. So check if empty. If empty, return 0 because you cannot pop out of an empty stack. There is nothing to pop. Else, if it's not empty, you have to store array of top somewhere. Okay, array of top. Handwriting's bad. And then decrement top. Decrement top and then return 1 indicating a success. Okay, let us program this. So going to my terminal again. Yes. I'm going to put the return type to int again as we are returning a success or a failure. What do I need to pass? I need to pass the reference to my stack. Okay, so stack stars, and I also pass a reference to an integer variable. This address is where we are going to store the popped value. As we are not returning the popped value, we are just returning if it's a success or a failure. I will store my popped value at this address X. So we'll just pass the reference to some integer. So where we are going to store our pop value. So first we are going to check if the stack is empty. So if my stack is empty will return 1. I'm going to return 0 because I cannot pop from an empty stack. So then what am I going to do? I'm going to store the top element. In this case, I'm going to store it at the address. So how am I going to represent the value at an address? I'll use the star operator. So star x, this represents the value at x. I am setting it to the top the uh, value at the top index of my stack. Yeah, this is how I do it. And then I have to decrement my top, not directly top, as a top. And I'll return a 1 indicating a success. Return 1. Yeah, this is my pop. Again, lines 35 and 36 can be compressed into a single line. Here we are accessing the top value. Here also it's not top, it's SS top. SS top. And here let us put it in brackets just for I don't remember the priorities exactly. So yeah, this will make sure we won't run into any errors. So here, instead of line 35 and 36, as we are accessing the index first and then decrementing it, we can use the post decrement operator in the array index itself. So we can do something like this. Minus minus. This will first use s dot top for the array index and then decrement it. So yeah, again we compress two lines into one line. Yeah. So what we have done push, we have done pop is full, is empty in it. We are finally left with our peak. So our peak is very similar to our pop operation. There's only just one minor difference. As I spoke in the starting, the only minor difference is I'm not decrementing top for peak. So for peak, again, in case of an empty stack, there's no meaning to peak. There is no top element to peak. So I'll write the pseudo code for this. So check if empty, empty. If empty, return 0 because there is no meaning like peeking in an empty stack. There is nothing to peek. Else, store array of top. That's it. We don't need to decrement anything because we're just looking at it. We are not deleting anything. So yeah, this is it. Now let us program our peek function. It will be very similar to our pop. So peek function, I'm going to put a return type as int. So stack, I'll pass a reference to a stack. I'll also pass the reference to an integer where I'm going to store the value which I peeked. So same as pop, I'm going to look at the top element, store it at this. I'm going to store it at this address x, but I'm not going to decrement the top. That's the only difference. First, I'll check if my stack is empty. If it's empty, there's no meaning of peek. So I'm going to return 0, indicating a failure. Now I'm going to store the value. So I'm going to set the value at the address x to be equal to the top element of my stack. That's it. And I'm going to return a 1, indicating a success. So yeah, these are all the stack operations. Push, pop, peek, and is empty and is full, and my init function. In a future video, so this is the array implementation of the stack. So let us just compile it and see. Yep, there's no errors. We wrote it perfectly. So yeah, in a future video, I'm also going to upload the linked list implementation of the stack. So now let us look into the time efficiency, like time complexity of each function. Okay, let us come to the push function. Push function, it just puts increments one variable and inserts at the end of an array. So it is O of 1. Similarly, even pop function decrements a variable and accesses an index of an array, which is also O of 1. Even peek does the same thing as pop, so that's also O of 1. So all the for a stack, push, pop, and peek operations must always be done in constant time. So yeah, this is our array implementation of a stack. Thank you for watching.